Hello. So a friend of mine has been getting into cabinet making, possibly getting into an apprenticeship or something like that. We were talking briefly the other day, and I'd mentioned how my time in cabinet making and stuff led me through to CAD and CAM and getting into that area of my career. And he just inquired about it. And I said back to him that I could make a video to sort of explain some of that stuff. So that's what we're seeing here. So it's basically just a guide to the most simple steps because he did mention to me to just say that I know nothing, if you know what I mean. Like that's the starting point sort of thing. So I haven't assumed anything here. Basically, it's just a complete, a walkthrough as best as I can put together sort of thing for you. So in the first slide there is what is CAD? CAD means computer assisted design. So the term CAD applies to any computer generated design to be used in real life. So you have a CAD model, a 3D CAD model, a computer assisted designed model sort of thing that you can use to extract information from and stuff like that. So you did mention at the time, and it's something that a lot of people have a misconception about sort of thing. And it's also, you'd mentioned about like giving you the right tools when you walk in to talk to people and stuff like that in that industry. So AutoCAD is the name of a product supplied by Autodesk, a CAD/CAM supplier. AutoCAD is a vector-based modeling program which generates skeletal drawings, which can be used to generate skeletal models, I should have had in there, which can be used to generate drawings. Actual modern programs are much more powerful than this, and even AutoCAD nowadays has been replaced by Inventor in most applications. Now, I use that loosely in most applications because I know a series of guys that are still using older school CAD programs like AutoCAD and stuff like that, 2D things, because they're much easier to run on lower computers. Inventor and SolidWorks and all these sorts of things, they do take a considerable amount of resources. In the case of FEA, that's FEA and graphic design end, that's when you're really testing a computer. Like playing computer games and stuff like that, you get a little bit of a test out of it, but that's why you see these insane megahertz numbers and insane gigabyte numbers, and it's like, oh, my computer can do all that. And it's like, yeah, but put it on a CAD program and see how many, how many different, how many degrees of freedom can you leave in an FEA sort of thing and have your computer pump it through. That'll impress, that impresses me. Anyway, so let's get back to it here. AutoCAD is the name of a program. CAD is the name of the process of computer assisted design. AutoCAD used CAD in their name, and Autodesk have used CAD in that product's name, which is a little bit scammy in my opinion, because there is now a great deal of people out there who refer to CAD as AutoCAD. So you'll say like, oh, do you know CAD? And they're like, oh yeah, I know AutoCAD. And it's like, so do you mean you know CAD, or do you know how to use AutoCAD? Like, so yeah, that's something to just give you the right tools there. For the purpose of this guide, we'll be talking about SolidWorks and SketchUp. Now, in the industry that you're working in, if you're working in cabinet making, it's most likely that they'll be using a program like Cabinet Vision or something like this that can export a CAD model directly into a CAM program, or can CAM a three-dimensional model using all the parts that it can just DXF them straight away and stuff. There's some very clever programs that are made nowadays specifically for cabinet making as far as CAD, because that industry obviously now thrives around a lot of machines and stuff like that, and has become very, very commonplace for them. But programs like SolidWorks and that are engineering programs. It can do all these other things as well, but it's not so much specifically a cabinet making program. So if you're in the cabinet making industry, you're probably looking at Cabinet Vision and other, like there's a whole bunch of them now. I can't honestly even list them all off. Okay, so the next slide there is what is CAM? CAM means computer assisted manufacturing. This refers to the machines which are computer driven by geometric code, referred to as G&M code or just G code. The M refers to the internal miscellaneous codes used for the machine offsets and tooling, or M codes. So, like if you want to rehome, like reset an internal home position, if like tool changes are T code. So there's M codes run a lot of different things in the machine, sort of thing. That's why you'll hear it referred to as G and M code, but really it's just geometric code sort of thing. So G code is what a lot of people refer to it as, and that is the code that a lot of the machines use to cut and make the parts and everything like that. So G codes are generated via a CAM program, so via a computer assisted manufacturing program, based off data supplied by the CAD model. An example is a DXF file can be extracted from a CAD model and then can be easily run through a CAM program to generate the required G code or G&M code. For this guide, I will be talking about SolidWorks CAM, and I will give reference to the CAM mods available for SketchUp. So you did mention the other day that, and this is the general note too for anyone out there, nesting machines, or running a nest sort of thing, is just putting a whole bunch of parts or a whole bunch of DXFs into a single bigger DXF, basically. So you can actually manually create your nestings if you wanted to. Like, I can create an assembly or something like that in SolidWorks, lay out all the parts within a 1200 by 2.4 area or whatever the material size is that I'm going to be working off. And then image that into a DXF or something like that, and therefore create my own nest. However, there are nesting programs, and that's awesome because let's say if you've got an entire kitchen, so I'm talking overheads, multiple lower cabinets, island bench, like just heaps of stuff in there. So you can nest all of that stuff at once. Basically get all of your parts DXF, throw that into a nesting program. It'll nest all of them really efficiently to give you the most minimal amount of waste and stuff like that. And then afterwards you're just working with the machine on, for example, sometimes if you've got a machine that doesn't have enough suction on its bed and stuff like that, or if it's nesting smaller parts out towards the edges of the sheet and stuff like that, you still really need to work with the machine and try to hold those parts down and stuff like that as it's cutting it, or try to help the machine out a little bit. So yeah, I think so you get that bit. That's just the CAM side. So there's CAD and there's CAM, two different things. Machines in cabinet making. Machines in cabinet making have become commonplace. It's important that modern cabinet makers understand these machines. The most common machine seen in the cabinet maker's factory is the CNC router, probably a nesting, the beam saw, edge banders, and auto assemblers. So auto assemblers aren't as commonplace as, let's say, a beam saw and an edge bander. Just about every cabinet making place out there should have a beam saw and an edge bander sort of thing. If not a beam saw, then at least like a bench saw or something like that, just for cutting straight up square components, multiple at once, so you can lay out 3 or 4 sheets at a time, cut multiple bases, multiple backs and everything like that. You can still keep up with a CNC router on bench saws and beam saws and stuff by just running multiple sheets at once and stuff. But for the most part, if you're cutting anything complex and if you want to eliminate the need for your assemblers to do anything, i.e. measure, like if you have a CNC router and it's setting out all your gear, the guy should not need a tape or a pencil. All that they should need is a drill. And if you've set your machine up correctly and the tooling and everything like that correctly for it, then that's all of the tools that should be required. I've worked in multiple cab shops now where they've been able to get it down to that level of perfection and stuff. And I myself have actually run a cab shop, where we were able to get the efficiency levels working, where it was just like, guys should only have a drill. Now this gets confusing for people, as you've said before too, because it comes down to plans and drawings and stuff like that. But anyway, In the next slide, engineer to assembler. Some hints for assemblers from an engineer. Now, I'm not saying it's like, I'm an engineer, here's a hint for you assemblers. I'm a carpenter. I build this stuff, if you know what I mean. I do every single stage of this process for myself and everything. So it's not, I say that these are hints because when I've worked in factories and stuff like that before, this is where I've seen people get things really confused. And I've seen cabinet makers arguing with the designer and stuff like that about stupid things that don't matter. So, anyway, I just thought I'd make this bit some hints for assemblers from engineers. Is if you think the machine has cut the part wrong, this means that you've assembled it wrong and are not following the instructions. If you want to try to tell your designer, hang on, I'll explain the rest. The machine only makes errors that are also seen in the CAD model. The machine cannot, under any known circumstances, perform a 100 mil trick unless instructed to do so by a human. So if you get a part and it is, hey, it's 16 mil too small or something like that, there's a thing called a C value, which is essentially like the tool's offsetting and stuff like that. Depending on the CAM program that you're using, most of them are pretty bloody intelligent this way and shouldn't stuff up. But I've seen some machines out there that do. So basically it's like if you're cutting with an 8 mil bit and your part's 16 mil too small, then there's a hint to you to say that, I probably cut on the wrong side of the line, so its C value in the coding was probably wrong. See, now going to the designer and saying, these parts are cut wrong, I need to cut all of these parts myself now, and stuff, that doesn't help him get to the cause of the problem. So if the assembler himself has the ability to understand the machine and the entire process, it becomes an extremely simple system then to just be able to walk up and say, hey man, part 75106 has a C value offset wrong, can we just swap that to the other side of the line please? And he can then go, yes, excellent, I know exactly that part, I know just where that is in the system, I'll jump in now and I'll try to swap the C value and I'll redo the nest for you straight away. No dramas. So understand all of the steps in between helps the process run faster. The machine works to a tolerance of like, 1,000,000 decimal points or some crazy shit like that. Most of them work to about 6 or 7 like decimal places and stuff. I've worked with Anderson machines that, I honestly don't know how many numbers it was lifting off in its decimal places, but the bottom line behind that is that if you read on the plan that the part is 362.758 millimeters, then yes, it is actually 362.758 millimeters, or the machine offsets have been compromised. Now, the reason that this matters is because when you're building a kitchen in a long run and it's been designed to meet a certain span, you might get because of, so let's say as well too, that you're using a foil board on a melamine or something like this, so your sheet size is actually like 16.3 millimeters or something like that. Now if we have 16 gables between one wall and another wall and we don't take that 0.3 into equation, then we have an accumulation of 0.3 by 16. So then at the end of this run of cabinets you get a gap of like 10 mil or something like this. Well, it did not work, it did not fit to the required measurements, and now the assembler will have to make fudges and adjustments and stuff like this on site to try to fix that. So that's just something to keep in mind for a lot of assemblers and stuff like that out there, because one of the most commonly heard things from assemblers is, why does it say fucking 0.758? You show me 0.758 on this tape. It's like, mate, don't run out of, why you got a tape? The machine cuts it to that, and that is why it is that. If you get to a point where you're like, Oh, but I've got to now, let's say that part got damaged. I've got to go and recut that part. Run it in the machine. It'll give you the exact thing. If not, then recognize that your human eye can't perceive that level of accuracy sort of thing. So if you want to cut it yourself, probably just go for either 362.5 or like 363 or whatever the closest thing that you could get it to in production, you know what I mean? And just bear in mind that now it's going to be out that fraction here and there. And this is all real stuff. I only know this from experience and having done it before, you know, because I've been there on the floor before having arguments with engineers going like, mate, show it to me on this tape. It's like, dude, it matters. It's like, and it really does ultimately, especially with tool sizings. If you're using Imperial tools and that, they're going to have stupid offsets, you know, ridiculous microfraction offsets and stuff like that. Use whole number fucking metric tools. It's awesome. Last thing is engineers and assemblers are the same thing. Argument between assemblers and engineers are just the result of poor communication. Both jobs have frustrations, and the best way to master the process is to learn to do every single step yourself. This gives you a greater appreciation when people come to help, as you know the struggle of each task that you ask them. Now, the point that I'm trying to get across there is that factories have a series of people who are in an industry that is a whole. So for a designer to be arguing with a cabinet maker, it's like, hang on a second, aren't you guys all the same thing? You know, like, mate, if you're designing it, didn't you know how to do his job? So don't you have to be that to do that? And you don't see that in factories. So somebody might be hired that's just from outside the industry. They're just not part of it. I myself, as a carpenter, when I got into cabinet making and stuff, I had to get past that concept of not everything's set out for you. You work to the parts, which I'll do another video later to show you that. But basically, yeah, you don't set out as a cabinet maker, or if you are, you're doing it old school. Basically, you can still build things old school. There's nothing wrong with that. But if you're trying to be highly competitive in an industry that is constantly moving forward sort of thing, then you're probably going to be working with machines. And it's about mastering the art of assembly, which is IKEA, Caboodle, all these sorts of guys. And ultimately Caboodle do everything just by standard. Like, you go in any cabinet making place out there and they're basically building the cabinets and everything the exact same way Caboodle does, the exact same way every other cabinet maker is, and stuff like that. All that they've done is, you know, harness the power of drawings and CAD and CAM to be able to perfect their system down to a level where they can give it to you in boxes and just say, just follow the piece of paper, mate, and you're fine. And if you make any mistakes, they can ultimately come back to that bit of paper and say, did you do that? Did you do that? Did you do that? And it's like, yeah, I did that. Well, if you did that, then that can't happen, sort of thing. Because it's just a series of eliminating problems to create an ultimate line of efficiency, sort of thing. And that's the addiction that I found in the cabinet making industry. I started on the floor, started building cabinets, doing all that sort of thing. I wanted to learn more about these machines. They wouldn't teach me. No one would show me. I had to teach myself. I ended up getting better at this than a lot of the people that were there. I ended up running that cab shop. I ended up getting, you know, like poached on to work with other people and stuff like this to move upwards in the industry, because just by embracing that is part of the industry and getting to know some of these machines, you can make yourself invaluable. I know guys that have been in the cab shop, like, this guy's been running the machine now for 15 years or something like that. Mate, you've been running machines for 15 years. Yep, that's it. 15 years I've been doing this. Or I work with, you know, mills and lathes, and that's awesome, man. You know, how do you work with sheet metals and that for your folding angles when you're getting lines in your CAD when you set up? So I don't know how to do any of that. So hang on a second. That means that you spent 15 years pressing the go button. You know, like, there's a chance to get in to do more than that. and it doesn't come, like, I had to do it all myself. You know, if you're interested in it, you can get stuff like this for your computer. Work with SketchUp. It's like an easier program to get. It can be very, very cheap and stuff too, an affordable program, and it gets people into CAD. That's where I started off with it all. Yeah, so that's about it for this one. I've got another video where I actually show you all of the CAD and the cam side behind it, but this is, you know, it takes fucking ages. This is already up to some ridiculous time, so. All right, man. I hope it helps or something. Cheers. Bye.